Let's begin by rewriting our question here. Now, reading this from left to right, we have 2 minus and then a set of brackets. Well, we must always tackle our brackets first. However, inside these brackets, we have another set of brackets. And inside of these brackets, we have another set. So we're going to tackle this set first and work our way from the innermost brackets to the outermost. 2 minus 3 is equal to negative 1. 1 minus negative 1 minus 2 is equal to 0. 1 minus 0 plus 3 is equal to 4. And finally, 2 minus 4 is equal to negative 2. So our answer is B. To begin, let's list all of the possible values for A, B, C, and D. Now, judging from our answer choices, we see that the product of our four integers will be negative. Now, there are two possible ways in which the product of four integers can be negative. Case 1 is that we have 3 negative numbers multiplied by 1 positive number. Case 2 is that we have 3 positive numbers multiplied by 1 negative number. Now notice that the magnitude of our positive numbers is greater than the magnitude of our negative numbers. So we want to include as many positive numbers in our product as possible. So to create the least possible product, we're going to use the following numbers. When we do so, our product is negative 4,320, so our answer is E.
Certain barrel is 1/5 full. When K liters of liquid are added to the barrel, it becomes 2/3 full. In terms of K, what is the capacity of the barrel in liters? Okay, so we want the capacity of the barrel. That's what we're solving for. So we're going to need a little bit of room to do the calculation. We'll get rid of the answer choices. Let's say B is the capacity of the barrel. That's what we want. We have 1/5 of B plus K equals 2/3 of B. Well, one very good way to get rid of fractions is just to multiply everything by what would be the common denominator of the fractions. Well, we have a 5 and a 3, so the common denominator would be 15. Multiply every single term on both sides by 15. So here we'd get 3b plus 15k equals, and 2/3 times 15, 15 divided by 3 is 5, 2 times 5 is 10, so that's 10b. So 15k equals 7b, and we want to solve for b, so divide both sides by 7. 15 over 7 times k equals b. We want 15 over 7k. 15 over 7k, answer choice C.
The fastest way to solve this question is to convert each fraction into a decimal and then to arrange these values in ascending order and choose the middlemost value. Now, one way to convert fractions to decimals is to use long division. So, for example, to convert 1936 into a decimal, we divide 36 into 19. This is one method. I want to show you a second method. Now, before we begin doing any conversions, we could recognize that we can eliminate two of our answer choices. We can eliminate A and C. Why can we do this? Well, notice that all of our fractions are all very close to 1/2. However, 1936 and 6/11 are both greater than 1/2, where the other three fractions are less than 1/2. What this tells us is that our fractions 6/11 and 1936 are both going to be our two largest fractions. Now, it doesn't matter which one's the largest and which one's the second largest. All that matters is that these two fractions cannot be the right answers. So now we have to convert the other three fractions into decimals. We'll begin with 12/25. To do this conversion, I want to rewrite this fraction as a different fraction with 100 as its denominator. To accomplish this, I need to multiply the numerator and denominator of our original fraction by 4 to give us 48/100ths, which is equivalent to 0.48. Our second conversion, 5/11. I want to rewrite this fraction as a new fraction with 100 as its denominator. What do we multiply 11 by to get 100? Well, we know that 9 times 11 gives us 99, so we need to multiply 11 by a number slightly larger than 9. I'm going to use this notation. This means I'm multiplying by a number slightly larger than 9. So once I do this on the denominator, I also multiply the top of the numerator by a little bit more than 9 to give me a number slightly larger than 45, which if we convert to a decimal is equal to a number slightly larger than 0.45. And finally, I want to convert 8/18. First, recognize that 8/18 is equivalent to 4/9. And now I want to write 4/9 as an equivalent fraction with 100 in its denominator. What must we multiply 9 by to get 100? Well, 9 times 11 is 99, so 9 times a number slightly larger than 11 will give us 100. Now we multiply the numerator by a number slightly larger than 11 to give us a number slightly larger than 44. And this converts to be equal to 0.44 plus a little bit more. From here we can see that our values in ascending order are 8/18 is the smallest number, followed by 5/11, and finally 12/25. Since 12/25 is our middlemost number, we know that the answer is B.
This is a tricky one. For positive numbers p and q, p minus q over p plus q equals 2/3. And we want to compare the value of p plus q to 5. Well, let's think about this for a second. First of all we know is that p and q are positive numbers. This doesn't necessarily mean they are integers. They could be fractions, they could be decimals, they could be any kind of numbers whatsoever, any numbers on the number line as long as they're positive. So, if we have a fraction that equals 2/3, well, let's think about that. A fraction equals 2/3, that could be 0.02 over 0.03. That fraction would equal 2/3, and in that case, p plus q would be a tiny decimal. A fraction equal to 2/3 could also be 2,000 over 3,000, in which case p plus q would equal 3,000. So in other words, we could make the denominator, p plus q, we could make it either very small or very large. And this means we have no way of determining what its size is compared to 5. And therefore the answer is D, the relationship cannot be determined.